Hello everyone, in this video let us understand the concept of velocity time graph. For that we'll be looking at the motion of the object and position time graph. From that we'll be constructing the velocity time graph. To start with, when object placed at -8 meters and it would be moving with instantaneous velocity of 0.7 meter per second, and it would be moving faster and faster as a function of time. This is how the motion would appear. It starts here and goes all the way to right. So let us look at the graphs. So this is at t equal to 0, the position is at -8 meters. Now this is the position time graph for the entire time history of 52.12 seconds. And on the velocity time graph, the initial velocity of 0.7 is put. At t equal to 0, it is 0.7, and at the end of the simulation, which is 52.12 seconds, the velocity would have been 3.82 meter per second. So at end of the simulation it is somewhere around 3.82. So let us observe this. Let us observe the position of the object as well as position time graph, and this dashed line is a tangent drawn to the position time graph at that instant of time. For example, at 5.21 seconds the velocity is 1.01 meter per second, somewhere here 1.01, and this is the tangent. So we'll be taking equal steps of time and observe the position of the object. We can see the spacing is increasing. So at t equal to 26.06 seconds, the velocity is 2.26 meter per second. Similarly, we can take equal interval times time. We can see that the distance traveled in equal interval of time is increasing. That means its speed is increasing. That can be seen here as a function of time. The speed is increasing. So let us draw more points by drawing more and more points in between. You can see this is the tangent at 22.93 seconds. The slope of that tangent would be 2.07 meter per second, and that would be put there. Similarly for all instances of time. So as the speed is picking up, the position time graph is bending towards y-axis, and velocity time graph is a straight line making a positive slope with x-axis. Now let us observe a case where the object is moving towards the left. And put the object somewhere on the right side. So the object is at 14 meters and the motion would occur on the left side. Keep track of the color. The blue color is towards moving left, and the red color indicates it is going faster and faster. Same color scheme will be used to put the dots. So this is at t equal to 0, it's at 14 meters. So this is the position time graph. Observe the color. The blue indicates it is moving towards the left, and the red circle around it indicates it is going faster and faster. So at end of the simulation time, which is 53.67 seconds, the object would be moving at -4 meter per second. T equal to 5.3 seconds, t equal to 10.7 seconds, and at t equal to 16.10 seconds, the velocity is -1.6. So as the speed is picking up, the distance between two lines here would increase as it is covering more and more distance in the same interval of time. Now we can observe in the earlier case where the object was moving towards the right, we got a straight line making a positive angle with the x-axis. Now since it is moving towards the left, the velocity time graph is straight line making a negative angle with the time axis. So let us put more points. So you can see the color scheme. The blue inside is for velocity, that means it is moving towards the left. Red circle is for indicating that it is going faster and faster. Now let us simulate the velocity time graph for an object moving towards the left with instantaneous velocity of minus 3.5 meter per second at t equal to 0, and it would become slower and slower as time passes by. So the object is at initial position of 14 meters. Let us observe the motion. It comes to a stop. So this is the position time graph, and we have put minus 3.5 meter per second at t equal to 0. This at the end of the simulation as it has stopped. So we can see the velocity is 0, starting from minus 3.5 meter per second. It has become 0 meter per second. We can observe the physical distance. It is becoming smaller and smaller. And at t equal to 29.16 seconds, the instantaneous velocity is minus 1.75. So we can see it is a straight line again, where the end point is on the 0 line. It starts with a negative velocity, and at the end it becomes 0, and it has a positive slope with the time axis, but its starting is in the bottom coordinate and ends at 0. Now let us look at a case where the object is moving towards the right and it becomes slower and slower. The object is at minus 6 meters. This would be the motion. A red dot indicating it is moving towards the right, and so this is the position time graph, and at t equal to 0 it is 3.5 meter per second, t equal to 0 it is 3.5 meters, and a blue circle with a red fill. And this is at end of the simulation, 58.33 seconds. The object has stopped, hence it is 0. So let us observe in between. We can see the spacing is progressively becoming smaller and smaller. So is the curve bending away from the y-axis, and velocity time graph is approaching the 0 line. So we can see this is a mirror image of the earlier case where the object was moving towards left and it was becoming slower and slower. The line was like this, making a positive slope with the time axis. Now here it is making a negative slope with the time axis. Now let us observe the case where the speed remains the same. So throughout the motion the speed would remain the same. So the object is at minus 6 meters. Let us observe the motion. The black circle indicates that it is moving with a uniform speed, and the red dot indicates that it is moving towards the right. Now let us plot the graphs. So as you know, the position time graph is a straight line making a positive angle with the time axis. Both the tangent as well as the position time graph are overlapping for the entire time because it is a tangent. At the end of the simulation also it is 3.1 meter per second because velocity is not changing. So this would be a trivial case. So when the motion is a uniform velocity, the velocity time graph is a trivial case where it is a line parallel to the time graph with a magnitude of the velocity, that is 3.1 meters. We can see the spacing between successive positions is remaining the same. And finally, let us observe the case where it moves towards the left, and again the speed doesn't change. Object is at -6 meters. Let us observe the motion. It goes towards the left. So the object is moving towards the left. That's why the position time graph is in this quadrant, and at end of the simulation also the value is same, that is -3 meter per second. Hence the value doesn't change. For the object moving towards the left, it is a line parallel to time axis but in the bottom coordinate.